In this video, we'll be exploring what hexadecimal is and how we can convert between it, binary, and denary. We'll be doing a lot of binary and denary conversions in this lesson, so I'd highly recommend that you watch our last video on that if you're not comfortable with this topic yet. From our last video, you'll remember that humans count in denary, where we have 10 digits, the numbers from 0 to 9, to represent all of our numbers. As you can see from this example, when we get past the number 9, we add an additional digit to the front of the number. You'll also remember that computers work in binary, which is a base 2 number system, so it represents all of these numbers using only zeros and ones. You can see on the table how the binary number system is able to count to 15. Hexadecimal is a base 16 number system, which means that you have 16 digits before you need to combine two numbers together. This creates a complicated problem for us humans, as we only have 10 unique number characters for counting rather than 16. To get around this, we use the first few letters of the alphabet, meaning that in hexadecimal you count to 15 by using 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then go to the letters of the alphabet, so A, B, C, D, E and F. If you then wanted to represent the number 16 in hexadecimal, you can do so by writing 1, 0. While computers don't really use the hexadecimal number system that much, they are very useful to computer scientists, as one hexadecimal digit represents 4 bits of binary data, which is also called a nibble. This allows us to much more clearly represent large values in fewer characters. It's used for a wide variety of applications, including for colour pickers, computer MAC addresses, and for representing memory addresses. You'll need to know how to convert 2-digit hexadecimal values into binary and denary for your exam. It's much easier to convert hexadecimal values into binary and then convert the binary values into denary, so that's what we're going to do for this video. If we're looking to convert the hexadecimal number C3 into binary and then into denary, we first draw a table with 8 columns. Because one hexadecimal digit represents 4 bits of information, we can split the table into 2, with each of the halves containing 4 binary bits of data. We start by looking at the hex value of C. We know from the table earlier that this represents the number 12, so we calculate the binary value of 12 on the left here, first by subtracting 8 from 12, which gives us 4. As 4 is bigger than 0, we put a 1 in the most significant bit column and carry the 4. We then move on to the next column, where we subtract 4 from 4, which gives us 0, so we put a 1 in that column and then fill the rest in with 0. We then do the same for the second digit of the hexadecimal value. So, we subtract 8 from 3, which gives us minus 5. As minus 5 is negative, we put a 0 in that column and then carry the 3 on. We then try the next column, so we subtract 4 from 3, which is minus 1. As this is also negative, we put a 0 in that column and then carry the 3 on again. We then try with the next bit, so we subtract 2 from 3, which gives us 1. As 1 is positive, we'll put a 1 in that column and then carry forward the remaining 1. So then we subtract 1 from 1, which gives us 0, so we put a 1 in this column and we're done. So if we combine these two nibbles, or these two halves of the table, into one 8-bit binary number, we get the binary representation of the hex number C3, which is 11000011. We can then convert this number to decimal by using the steps we covered in the last video. We do this by writing out all of the binary values, so starting from the left, that's 1, 2, 4, 8, 16, 32, 64 and 128. And then we multiply these values by the actual binary digits. Adding these up gives us 195, which means that the hexadecimal value C3 is 195 in denary. So what about if we want to go the other way round, so converting denary to hexadecimal? Well, first we convert from denary to binary. We've done this quite a few times by now, so I'll quickly summarise how we're going to do it. Firstly, we'll write out our binary table and move from the most to the least significant bit, trying to subtract the bit values from 64. If the subtraction is greater than 0, we'll put a 1 and carry the result of the subtraction, otherwise we'll put a 0. After following this process for all of the bits, we get the binary value of 01000001. To convert this binary value into hex, we'll split the table in half so that we have 2 groups of 4 bits, or 2 nibbles. We'll write out the binary values of these nibbles, so 1, 2, 4 and 8, for both of the nibbles, and then we'll multiply these values by the actual bits of the binary to calculate what the nibble values are. In this case, that's 4 and 1. So we combine these two values together, so our hexadecimal number is 4 and 1. So there we have it. In this video, we've learned about hexadecimal numbers and have learned how to convert them to and from binary and denary numbers. That's the end of this video. If you'd like to test your knowledge and access other lesson resources, then make sure to head on over to revisio.uk.